We're going to go over our test review for solving quadratics. This is our Unit 9 test. A good chunk of this you can do on the Desmos calculator. A couple of them you'll probably need to use your yellow calculator. So hopefully you're feeling pretty good about this material. If you have any questions, please make sure you ask. Number 1 is talking about the total number of seats in a movie theater can be modeled with the equation, and X is the number of rows. So please pay attention to what is being represented. And then it's asking about how many rows. So it's asking about X. So that tells us that we're going to look for our rocks, our roots, our zeros, our x-intercepts, our solutions. It says there are 713 seats, right? And it told us number of seats is modeled by this equation. So this is our Y. So we need to plug in that 713. And then remember, if we're going to look for those roots or solutions, we're going to have to set this equal to 0. So we're going to have to move this 713. It's a positive, so we're going to undo it with a negative. So now we're equal to 0. Our Y is 0, which is what we want for that x-intercept. So x squared minus 6x, a negative 7 minus 713. If you are unsure of that, negative 7 minus 713 is a negative 720. It's okay if you want to double check your work in the calculator just to be sure. And then, so that was our first step, right? We set it equal to 0. And now what we're going to do is we're going to graph this. And we're going to look for those roots. So we can go to Desmos here and say x squared minus 6x minus 720. You might need to zoom out a little bit so you can find your roots. So there are, in fact, two roots. We have negative 24 and we have positive 30. So we can say x equals negative 24. And remember, this is telling us our rows, negative 24 rows and positive 30 rows. Well, it doesn't make sense to have negative rows. So our answer is just going to be, doesn't make sense to have negative 24. So our answer is positive 30. Okay. When we look at number 2, gives us the height of an object after it was launched from a height of 3 feet, right? That 3 feet we can see right here. That's our y-intercept. What is the function, guys? So they want us to write the equation. So we do have, in fact, 3 points, which is important. We have negative 0.2 and 0. That's a root. We have 0, 3, and we have our other root of 3, 0. And so what you're going to want to do on this is number 4, list and spreadsheets on your yellow calculator. And we're going to do menu, not 413, because that's what we did in 8th grade for linear. 416 is going to be our function for quadratic. So we're going to go to our yellow calculator, list and spreadsheets. Remember, always label X and Y. And to write a quadratic, you have to have those 3 points. Okay, so we can come here, negative 0.2, 0, 3, and then over here, make sure your numbers line up, 0, 3, and 0. And C1 menu 416. All right, we're going to call the X list X and the Y list Y. Enter, enter. And this gives us our A, B, and our C. So I can come over here and I can write f of x, or I can write y equals, and we're going to just write it in standard form. And we get our A is negative 5. That always goes with our x squared. Our B always goes with x, so positive 14x there. And our C is by itself, plus 3. Number 3. Okay, which one is true? So this is very straightforward. You're going to need to set equal to 0. Now, notice that we do have two regular numbers, so we can put those together. So we get 0 equals 4x squared. A negative 53 and a negative 11 is a negative 64. You can, of course, use your calculator for that. After we've set it equal to 0, we can graph it. So we'll go back to Desmos, 4x squared. Oh, sorry about that. 4x squared minus 64. And I can see, in fact, I have negative 4 and positive 4. I'm going to go ahead and write that on my paper. X equals negative 4 and positive 4. Make sure you read all of your answer choices. The equation has x equals 4 as its only solution. Well, that is one of them, but it is not the only, so this is not true. We have no real solutions. That's not true. We had two. The equation has an infinite number of solutions. No, again, we only have two. It has x equals 4 and x equals negative 4. There you go. When we look at number 4, we talked about linear functions. Which of the following could represent the linear factors for the quadratic shown below, right? Solutions, these are our rocks. So I can see very clearly on this graph that I have, this is going to, if I zoom in a little bit, this is x equals negative 1, and this equals 5. So I can very well come over here and say B and E. And then we talked about, to write your linear functions, you need to take those factors and set them equal to 0. So if I want to make this equal to 0, I'm going to move my positive 5 over by subtracting it. If I'm going to make the negative 1 equal to 0, I need to add 1. So x plus 1 equals 0. And these are my factors. So now I'm going to choose A and I'm going to choose D. Number 5, the inequality got a little messed up there. Y is less than or equal to. So what you would need to do, and I would suggest that you graph this in Desmos to make sure, not with an inequality, but just graph these to see exactly where your points are. So let's start with that. We can say negative 3x plus 4. If you don't remember how to graph y equals mx plus b, and I can see here, I have 4. That's an ugly, ugly point. I have another one. Let's see if I can find another nice point. Oh, here's a nice one. Negative 1, positive 7. So I'm going to come back over here. Negative 1, positive 7. And my other one was 0, 4. Now, I want you to remember a couple of things. If you remember the tic-tac-toe board when we did this, we have solid and we have dotted lines. And then when we do inequalities, we have shading, right? So we have above and below shading. If it's solid, it's going to have that or equal to, right? If it's solid above, it's greater than, below is less than. That makes sense. And then dotted does not have the or equal to line. I don't have the or equal to line, so I'm going to go ahead and draw my dotted line. And when you do this in the computer and you graph these lines, you need to be very, very specific about where you put those dots. That's why I suggest putting it in Desmos and looking for those coordinates. I'm going to graph this 2/3 x minus 6 now. So I can say 2 divide 3. Make sure you arrow out x minus 6. And I can see here 0, negative 6 is a nice point. And then I have another one over here. It looks like, what is that? 6, negative 2. Okay, so I'm going to come over here. 0, negative 6, 6, negative 2. And again, there's no line underneath that inequality. So I'm going to draw my dotted. My first one was less than. I shaded below. Now this one, though, is a greater than. So I can see I need to shade above. And remember, your solution set is going to be here where they overlap. So my solution set, not on a dotted line. If it was a solid line, you could include it. Not sure why that keeps. So this right here is what would need to be shaded because this is where they overlap. And that's where all of your answers that make both inequalities true are. Number 6, we're looking at this graph. We have a quadratic here. You could graph each item in Desmos if you wanted, but you should know most of this vocabulary. Your vertex is your HK, where it changes direction. So 2800. It is a max because it's at the top. And the max value, this is your K. A lot of people on the last test wrote the H value or the X value. The max value is going to be your K or your Y value. Your axis of symmetry involves your H, right? So we're going through the X axis, X equals at 20. You have to put that X equals. Zeros, these are your rocks. So I can see here 0, 0 and 40, 0. So you could write it as coordinates like this, or sometimes they have it in set notation like this with the braces. The y-intercept is where it crosses the y-axis, and it also happens to be 0, 0. So that's kind of vocabulary from before. Number 7, what are the solutions? So this is just purely graphing. You can put this into Desmos. I'm not going to go through and do that. I'm going to go ahead and just write my answers because I feel like you guys are pretty good at graphing in Desmos at this point. These two, this one and the last one have no roots. So I will show you those. So what that means is, remember, it's not going to cross the x-axis. So we will look at those two. So x squared plus 49, right? I can zoom out, and my graph is way, way up here. It is not touching the x-axis. So that is why there are no roots there. Remember, you can have one root, you can have two roots, you can have no roots. And again, this is the plus 14. So you can see, in fact, that it is also above the x-axis. That minus 14 one did have some decimals. I just rounded. So you'll be able to do that as well. Number 8. What is the solution set? Again, solution set is going to be your rocks. You need to move this 3x over by undoing it. So you have to always set it equal to 0 first. And then you can graph this. So if we graph 2x squared. So a lot of this you can do in the Desmos calculator. Just make sure you read and pay attention to what it's asking for. So -2 and 3.5 are my roots. So I'm going to write x equals -2 and 3.5 and put that in braces. Then when we talk about linear factors, remember there are no fractions when we are writing our linear factors. So we want to write these separately. X equals -2. And I'm going to add 2. I want this to be equal to 0. So x plus 2 equals 0. This is one of my linear factors. This 3.5, if you aren't sure what that is as a decimal, remember in Desmos you have this little circle on the side, so 7/2. If you need to get rid of a fraction, we're going to multiply by the denominator, and then not -7, I'm sorry about that, +7, right? We're multiplying here and here. 2 times 7/2 is just 7. And then we would need to move that 7 over. 2x minus 7 equals 0. So these are our two linear factors, x plus 2 and 2x minus 7. If I look at number 9, more of the same. What are the zeros? Again, we're putting those in the graph. X squared minus 89. And we can see here, oh, I'm sorry, 289. Make sure we type it correctly. That's the first step in getting it right. Negative 17 and positive 17. I'm going to write them like this because then again, we're looking at our factors. So I would need to add 17 to both sides here. So x plus 17 is a factor. And on this one, I would minus 17. For the most part, if it's a whole number, you're just going to move it over and change that sign. Number 10 is talking about domain and range. You're going to need to graph this one, okay? Definitely graph to see that picture. So let's do that. Negative 1/2. And even though there's a parentheses there, we can still graph that. Negative 1/2 x minus 5, quantity squared. So we can see this, and I want you to notice a couple things. So it just keeps going down, down, down. And we remember x's are going to be left to right. So our domain is going to be all real numbers. And then our range, though, keep in mind for your pattern, we always have whatever our lowest is less than, in this case, it's going to be y because it's a range. If it was domain, it'd be x. Low and high. So if I'm looking at my picture, I don't have a low. It's just going infinite down, but I do have a high and it happens to be at 0, right? We're looking at our y values. So since I don't have a low, I'm just going to leave that less than or equal to 0. And because we could write negative infinity there, but there's no purpose. So our range is just going to be y is less than or equal to 0. The same thing on B, right? We definitely want to graph that and follow that same pattern. So this one is very similar. Instead of a negative 1/2, it's just a positive 2. So I'm going to go in here and edit this. And I can see now that it is going from left to right. It's still all real numbers, just keeps going up, up, up. But I do have a bottom now of 0. So my domain is still all real numbers, but I do have a bottom. Now I just don't have a top. So we don't need to write this other piece, right? If we wanted to, we could write positive infinity, but that's not necessary. Now, they are probably going to flip-flop that. They like to write with the letter first. And if you do that, you have to flip-flop that symbol, right? The open part is to the y, keep the open part to the y. So these are the same. Number 11, right? We've got a parent function and how did it change, right? So we definitely want to graph this and look at that picture. Okay. So when I graph my parent function, I will tell you it is always at 1, 1 and negative 1, 1, right? So here's my parent function. I'm going to do that one in red. I'll do this other one in blue. And we can always, of course, put that into our Desmos negative. Make sure you have that parentheses there. We need to remember also insiders lie. So when I look at this one I can see it has reflected over the x-axis. I have 0, 0 here, and then I have, what is this one? This is negative, this is positive 2, negative 1, and it would be the same on the other side. So positive 2, negative 1, negative 2, negative 1. And I can see this one. So we can say, first of all, because of this negative, right, we reflected over the x-axis. And then remember, again, because the insiders lie, and insiders, if you remember, that is going to be a horizontal change because it's inside. So we talked about the bar, lifting the bar versus doing the fly weight. So if we are going out on the fly, this is a horizontal stretch. Number 12, change it, right? We're going to move our 32 over. And even again, there's parentheses there. It doesn't matter. We can still graph that in our Desmos, right? And when we do that, we get x equals -7 and +1. So I feel like y'all are pretty good at that at this point. Number 13 gives us a graph. Now, which one of these is represented? You could graph all of these if you like to see which ones match, or you could do list and spreadsheets if you wanted, right? We have 4 points here, -4, 0, -2, -4. So like we did on number, I think it was number 2, we did list and spreadsheets. You could do menu 416. Or again, if you wanted to graph all 4 of these to see which one matched, it will be D. Number 14, more of the same, right? Graph this. It's already set equal to 0, which is very nice. And we get x equals -3 and x equals 5. So for my linear pairs, again, I'm just going to move everything to the same side. So x plus 3 and x minus 5. Those would be our linear pairs. So remember those linear pairs, you need to take your roots and then move everything so it's equal to 0. Here we have an equation. P is the profit in millions, so that's the same as our Y. X is years. How many years? So they're asking us about X. So this is going to be our rocks for it to be 160 million. Well, that is our money. So that's our Y. So we're going to write 160 x squared minus 8x plus 55. And again, in order to graph this, we have to set it equal to 0. So we will end up graphing x squared minus 8x minus 105. And we're looking for the roots. Now, this is going to give us 2 roots, but if we're talking about years, we have to only look at the positive root. So here's my negative root, but it doesn't make sense to have -7 years. My positive root would be 15. So that's my answer I'm going to write. So we're going to say 15 years, right? It doesn't make sense to use that negative root. So in like manner, number 16, what is the positive root, right? So move the 10. And again, this is all about reading carefully. -28x minus 10, right? When we graph this, we get 2 roots. 6x squared minus 28x minus 10, right? So I have this ugly decimal, -1/3, and I have +5. And they are asking us about the positive root. So I'm only going to write 5. All right, this one is talking about the length. Okay, there is actually a typo on this. This should be 104. So we're going to graph this. And what is the length? So we're looking at that rocks. So, but we're going to use x instead of L, okay? So we're going to say x squared plus 5x. But change that to a 104, not a 100, okay? And we have 8. We do have a negative number, -13, but you can't have a negative length. So our answer here is just going to be the length is 8 feet. So pay attention on those word problems, what it's wanting. More of the same graphing. Now this one does have a decimal. When we do this, we get x equals -0.75. This is asking about the linear factor, so we're going to have to make that a decimal, and x equals 10. Well, this x equals 10 is easy. We're just going to move that 10 over, so we get x minus 10. This one, though, we need to make sure we change this. And again, if you're not sure, you can always use Desmos. If I put in negative 0.75 and I click this little fraction, negative 3/4. So if I have negative 3 over 4, we have to multiply by that 4 to undo that fraction. 4x equals negative 3. 4 times negative 3/4 is just that negative 3. And then we're going to bring this 3 over. So my other root is 4x plus 3. All right, last two, quadratic function. So you have to identify your A, B, and C, but again, we're going to have to make sure everything is on the same side. None of these match. So we're just going to write it out. There is a 1 here. So my A is 1. My B is 8, positive 8, because I moved it over. C is negative 9. So you need to make sure that you can, in fact, set up your quadratic equation. You could graph this if it's asking about roots, but a lot of these, when it asks you about quadratic equation, you need to be able to set it up, right? So we have negative b. All right, well, my b is positive, so I'm going to make it negative. If it was negative, I would make it positive. Plus or minus the square root. Always put that b in parentheses. 8 squared minus 4. And I really like Desmos for this because you don't have to worry about, are you using the negative or are you using the minus? Right? 4ac all over 2 times a. And once you've got this set up, you can, in fact, then go through. You could simplify it individually, or you could put that whole thing in your calculator. Hit divide first so that you get your fraction. You have to do it twice. You're going to do it with the plus, and then you can go back and edit it and do it with the minus. Minus 4 times 1 was my A. My C was negative 9. Down here, 2 times 1, I'm just going to put the 2. So I can see, in fact, one of my roots is a 1. I can also go back up here, change this to a minus, and a negative 9. So x equals 1, x equals negative 9. Same thing on this one. This one's a little more complex. You would have to expand everything like we did in the last unit, right? If we're squaring this, if it's asking specifically for quadratic equation, now this one does say taking the square root of both sides. I apologize. I did not read those whole directions. So we would need to minus this 4, 2x plus 9 quantity squared equals 50. And then we're going to divide, right? We want to get that squared all alone if we can. Take the square root to undo a square. Now, keep in mind, when we take the square root, we get a positive or a negative. Square root of 25 is 5, because positive 5 times positive 5 is 5. Negative 5 times negative 5 is positive 25. So move my 9. Now remember, this is in fact two math problems. We have x equals negative 9 plus 5 and x equals negative 9 minus 5. So negative 9 plus 5 is a negative 4. Negative 9 minus 5 is a negative 14. Okay, good luck on your test. If you have questions, please be sure to ask your teacher.